Okay, so I gave it a little bit of thought during lunch, and we're going to need to need to invert the traversal that we did for the part one. So part one, the traversal was we needed to take the gold bag and then move up from that. So look at all the possible parents of a gold bag and then count those. And this one, we need to take the gold bag and traverse down the tree from there to get the count of possible bags below that. And it's a little bit complicated because we need to get it needs to be recursive, right? So it needs to, if this level, like let's say a gold bag can contain 2 red bags and a red bag can contain 3 green bags, you have to take the 3 green bags, multiply by the 2 red bags, and then sum that all together. So the product, the number of bags needs to be multiplied by the level that it's on. And I think we can do that. It's a pretty standard tree traversal. We'll just recurse through the child nodes. I'm going to separate these into part 1 and part 2 because they are so different. You know, a potential refactor down the road would be just to factor this into one tree. I don't know a good tree library for Kotlin off the top of my head, so I'm just going to write like a really bare bones, I'm just going to expose an interface method that will allow me to like take a node and get the children of it. And under the covers, I'm going to keep it in a map just like I've been doing. So let's start by, we do need a node, and so we need each of these nodes in this tree is going to be the color of the bag and then the count of bags that it can contain. So this node would be dark red with a count of 2. And I'm going to create that under this day 7. So I'm going to call it just a bag node. And this bag node is going to be a data class. And it's going to have a val of color, which is the string that we've been using to identify these. And then it's going to have a val of count, which is an int. And then that will be the val count I can type. So yeah, the color and then the int. And then I'm going to make a part 2 tree traverser. I might just call this bag tree because this will be reusable. There's like this, it's going to be the same tree. You could technically use the same data structure for part 1 and part 2 and just have a method that would be like parse downwards versus parse upwards, or traverse downwards versus traverse upwards. So I'm just going to call this bag tree. I'll probably refactor this down the line so that I can reuse it for both of these. But then it's going to take this. It needs to take in. Yeah, I mean, this is. Does it take in the input, the list of lines? I think I will. I might just have a parse method on it and then pass in a file name. Maybe I'll pass in the file and then I can still keep my file in my test directory. So I'm going to expose a static method on this companion object parse, and then that gives me a bag tree. And then the parse is going to take this is just going to be a companion object that has a method called parse. And then that gives me a bag tree, and then I'm going to have this file here, and then I'm going to put in I'm going to move this parse input here into this tree. Part 2. So maybe I'll have this be a private function here. This gives me a tree. And yeah, we need to figure out what we want to have as input here. I might actually this bag tree needs to keep track of a mapping of the string value of the node to the children which are going to be bag nodes which have counts associated with them. So we essentially need a this is exposing a little bit of the implementation details, but we're gonna have this val input. I'm gonna make this be a private val. Val input is a map of string to a list of these, I'm gonna do the same thing where I have a set of these bag nodes that we pass in. And those are the children. So to parse this input, this needs to be a set of bag nodes. And now we're going to invert this tree. So we're getting the root color. The root color is actually going to be the key for this instead of the value like we made it the last time. So we're making this tree of the color and then the children of that color. And we need to migrate over some of these methods. So this get contains bags and get root color here. Some of this is duplicated in that part 1 test. I'll worry about that later. It doesn't like this because it's expecting a set of bag node. And then for each, we're going to just invert this here. So the root color is going to be it contains bags line color map dot compute it. So this is computing the bag. We actually want to compute the root color as the key, and then the value is going to be a list of. We want to have bag. I think I'm going to call this child, just so it's clear. So child is going to be add, and then I'm going to create a. So we actually have to rewrite this parser because we need to keep track of the count. So this actually has to, this get contains bags actually has to return a bag node. So this is a list of bag node. So this is going to be an empty list. That's fine. And then we actually want, what we can do here is we can pull out the, we want a digit first. So this is contain 1 bright white bag, 2 muted yellow bags. So we have this input trimmed, and so each of our lines that we're looking at are going to be contain. Oh, so we actually, never mind. We've split that, right? We've split this, and so the input text is going to be like 1 bright white bag, and we want to just grab the digits here. So this is our string that we have that's trimmed. I'm going to just call this bag string to save it here, and then we need to find I will have it replace the bags here. With nothing. But then we need to actually grab out that bag string dot find. I don't know why that's complaining. I think I might just parse out. I'm first just going to parse out this number from here and then worry about trimming off the bags from the end of that string later. So we want to find, oh, it's a regex. We need to create a new regex. We're going to make this be of, this is going to be at the very beginning. We want a digit. And then we're going to group this in a parentheses so that we can just grab the, we want a digit, and then as soon as there's a space, then forget it. And then the regex, we need it to .find. We're going to give it this bag string, and then we want this to be .groups. It's the first group. And then .toInt, right? So this gives us a match group .value. Oops, dot. So this is going to be the val count. Is this one groups one dot value? God damn it, value dot toInt. Okay, so here's the count, and then the bag string. We'll do basically the same replacement that we did before, because before we were just parsing out the color, and now we need to additionally grab the count here. So I'm going to go back and go to that first part here, and then grab that color out of there and do that same trim and replace. So the color is going to be this bag string dot replace, and then I'm going to return a new bag node of color and count. And just for the sake of being clean here, I'm going to order these parameters here. We need to double backslash this, and I think I'm going to factor this since this is kind of a big method here. I'm going to map this into, or I'm going to have a separate function, private fun parse bag node, and then I'm going to pass in, I'm going to say directive. Is directive the right word? This is really a map of, I'm going to call it rule. Rule is string, and then this is going to be a collection of rules, and then we're going to parse that into a bag node. This is bag node, and then we can just factor this into this method. Replace it with rule, rule.trim, and then toInt, and return bag node of color and count. And then we're going to just map each of these rules to parse bag node. And I think I accidentally put this outside of the scope of this object, so put this here, and then that should give me a collection of bag nodes. So now let's just run a quick test of this. I'm going to make this not private, and then file name. Oh, I see. So parse the file. I think we can factor this into a single method. So we're going to add a bag tree, and then the file. We can just go. I mean, yeah. I'm essentially just. I'm going to just copy this here, and then paste it into here. And then this file is going to be, first we have to make this a bag node. And then we can just go file.bufferedReader, read lines for each, do this, new val.add. Mutable set. We want to add the. We don't want to add the root color. We want to add the child. And get contains bags returns a list of bag node. Okay, so it adds the child. And then we want to go return a bag tree of this with this input color map.toMap, and then that makes it, this toMap makes it immutable. And then we can get rid of this duplicated method. Okay, I think that'll work. We just want to make sure that, let's just have it parse this and just do a quick sanity check on it. I don't know why this is complaining here, saying that something's wrong. Oh, I see. Okay, I'm going to just call this bag test part 2. We can keep this constant here. I'm going to delete this traverse because the traversal this time around is going to be different. And we just need to grab that file that we were giving it. Call this day 7. Losing track of the days here in .txt. File is this, and then bagtree.parse file. This is an input stream. Whatever, I don't really care. We'll just call this an input stream. I don't know if I can just do this as file to file. Because it's getting it as a stream. Let's see, can I just do get resource? It's a URL. It doesn't matter. This is just handling the parsing for it. Okay, buffered reader read lines. And now this input is, we've exposed this input parameter on this bag node. So we can, or not bag node, bag tree. And then, so we can just we can inspect this. So I'm just gonna do println foo, doesn't matter. And let's see if it doesn't blow up. Okay, so we have this. Oh, I didn't, oops, didn't save it as a tree. I'm gonna save it as a tree. And we'll rerun that, and we'll take a look at that tree.input. Tree input, we have 7 parents. Let's say light red can contain 1 bright white bag. Key light red. So bright white, good, count 1. Muted yellow, count 2. Yep, looks good. Dark orange can contain a bright white and muted yellow, yep. Yeah. Yeah, and so we can just traverse this downwards and get all of the, we basically just want to get, the traversal is going to have to take a sum of the bags at each level and then multiply that by however many there are in the previous level. So I'm going to write a traverse count method. I wish that there was a way for me to draw on my iPad and share that on screen. I'm sure there is, I just haven't had a chance to look into it yet. But maybe I can explain what I'm going to do. I have it written down in front of me so I understand what I'm doing, and I'll walk you through this traversal as we're going through it. So we're going to expose a public function. We can make this private now since we've tested it. We'll expose a public function called traverse counts, and then we are going to just start with the shiny gold bag, but we might as well parameterize this. So I'm going to call it bag name, or bag color as a string, and then we can use it as input into this map to get this set here. And this is going to return an int, which is going to, this is going to be the count here of the possible bags that the gold bag contains. How many individual bags are required inside your single shiny gold bag? And then we can recurse through like we did before. I'm going to have a private method that's going to handle the traversal, and that way we don't expose this input map to other classes. We can encapsulate that. I'm going to have this traverse counts, and this is going to take a map. Although we don't. That's okay. We don't need to, since we're storing the map as input here. We don't actually need to be passing it into a method. So that's okay. Forget what I just said. So this traverse counts is going to take a bag color. It's going to return an int, and then that's effectively, this is going to be recursive, and it's going to return the sum of its children. So our base case is going to be that the node has no children, and then that's just going to return the value of the node. But we don't know the value. So why don't we make the input a node itself, and then it will return its value as the sum as the base case. So traverse counts. I'm going to do traverse children. I'm going to call it traverse child counts because this is a very specific traversal that we're doing. So the base case is this input of this bag node dot color is empty, or it doesn't exist. And I've already forgotten how to check that. So we're gonna go to bag test here. And I just want to check if that value exists. Contains key. Okay, yeah, so that's what we want. If not input dot contains key bag node, right? No, actually, it's either it doesn't, right? So if it's parsing all the children, I think we're going to ultimately have a key. I think we're okay. It's always going to have, every bag is going to either have no children or some kind of child as an entry in here, just because of the way that we're doing this. So this shiny gold bag is going to be a key. 2 dark red bags is going to be the value. So every time, it's not like the last time where there were some nodes that didn't have parents and they didn't have a record in this map. The way that we're parsing this, every input is going to contain a key. So we don't need to worry about that, but what we do need to worry about is if it has no children to begin with. So dot is empty. So if this is empty, we just want to return bagnode dot count. And this is probably complaining because it's a not a safe call. I think we're gonna just assert that this is safe. Oh, bagnode dot color, right? And then I think if we do this, we're just gonna assert that it's safe because we know. Whatever. We'll just give it an empty list. Empty list. Empty set. Okay, fine. So this is just a safe call that like this'll, if it doesn't have this, it'll give us an empty set, and then it'll check if it's empty, which is true. I guess the other thing, the cleaner way to do that would be get this bagnode.color and then have a safe call on this dot is empty, and then have a Elvis operator that just returns false. I don't know if it, oops, it's completely messed up. Bagnode.color. Oh, okay, that works. That works too. Okay. So then we're going to return the count. Otherwise, we're going to traverse the children. Otherwise, we want to get all the nodes that are down below it. Input.bagColor.map. And then we're going to have each of these is going to be a bag node, right? Why is that complaining here? Okay, I mean, this is, at this point we know. I don't know. I don't really care. This is fine. We know that it's not empty at this point. So compiler be damned. Then we're going to map this, and then we need to take the count of that node times the traversal of its child counts, right? So we're going to multiply, we're going to map this to an int, right? And then we're going to return this, and then we're going to do a sum. We're going to sum up the product of the child counts. But first, we need to convert this to an int. So we need to go it.count times it.traverse, or traverse child counts, right? Traverse child counts of it. And that's where the recursion happens. This is going to return an int, this count of bags. So like, yeah, we'll step through this afterwards. I don't know why this is complaining right now. So this is a list of int, and then we're just going to take the sum. Right, so that's good there. So that should be good. So the base case, we have this node. If it doesn't have children, then we just return its count. And then up above that, we have the count of the bags here multiplied by the traversal of the children. So I think that should be what we want. They did give us some input here. A single shiny gold bag must contain 1 olive bag and the 7 bags within it, plus 2 vibrant plum bags and the 11 bags within those. So that's exactly what we're doing. So this is the 11 is the children, and then this is the product of the number of the number of those children that the parent has, and then it's the sum of that. So this is that sum that we're doing here. So that should be good there. So let's test the example input test. So this file is going to be this day7.txt. The trees here and then tree.traverseChildCounts. We're going to create a bag node of, it doesn't really matter what the count of this one is. It's just going to be the, although are we counting the, so this is a little bit janky because we have to pass in a bag node for this, for the initial case, but we're not actually counting the gold bag among these bags. This is what it contains. And so at the very end, we're going to subtract off that 1 here. So the bag node is going to be shiny gold, and then it's going to be a count of 1, and then we're just going to subtract off 1 from that. And then count should be, we're saying that it's 126. No, we're saying it's 32. And then we can use this as another test for our input. But I'm pretty confident that if this works, that we are solving this recursively. So I'm confident that we can throw this at the full test, the full input. So we got a no pointer exception. Somehow, maybe this didn't exist. Is there a case where there wouldn't be a child in the... It seems like every child should have either... I'm going to set a conditional breakpoint here. The reason that this would throw a no pointer exception is if this didn't exist, right? I think that's the contract on here. So that would be a no pointer exception if the map doesn't contain that. So I'm going to set this conditional breakpoint. The condition is going to be if it doesn't contain this key, and then bagnode.color. So let's run this. We'll debug. Faded blue is the one. This is faded blue. That's really weird. So faded blue doesn't actually have an entry here. Faded blue bags contain no other bags. So what are we doing wrong? So let's say if line, oh, it's not actually, is it not actually mapping it? It contains bags. Empty list. Empty set. We want to, this is, we're doing everything as a set. Set a bag node. Empty set. Get contains bags. Parse bag node. And we want to do toSet. Oh, so this actually, I see. So if this is empty, this is an empty set, it's not actually adding it to the... we still do want to compute a map value for this if it's empty, and that's fine. What I'll do is, I'm going to say val children is this. And then I'm going to say if children is empty, we still want to create a value in the map, color map dot put root color, and then this children here. And then I think it wants to, yeah, this Kotlin stuff. And then this is gonna, since children is empty, it's just gonna skip over this, so it doesn't really matter. So now it should have a node for everything in there. So expected 32, actual was 146. The rules from the above example, faded blue contains 0 other bags. What are we doing wrong here? Is it that we're maybe, I wonder, let's take a look at this this traversal here. So we have shiny gold, and then the children of children of gold are, there's 2 of them. So we have plum. So I think the problem is, like, I think we're double counting here. So we're doing it.count, and then we're returning the count here. So I think we actually want to return 1 here because it's only 1 bag, right? And then maybe you have 2 of them. So I'm just going to return 1 as the base case. I think that's what the problem is. Because if a bag has no children, it can't have anything else. And in this case, so we actually don't need to pass in the node, actually. We can just pass in the color. And then we're just going to pass it.color here. So that's, yeah, that's fine. Okay, so now we should be able to do this. It returns 1. Type mismatch, inferred type, traverse child counts. Oh, I see. So then in this case, we don't actually need to do this whole janky thing where we're subtracting 1. So then we can just pass in shiny gold and delete that extra space. Damn, we're so close. So we got 29. We're expecting 32. What's the problem? What is the problem? It almost looks like we're not counting whatever this is. I think we might be not, because this is kind of suspicious. So a single shiny gold bag. It almost looks like this 3 that we're missing is this 1 and this 2 here. So I think we're not counting the intermediate bags is the problem. And to test that, I'm going to walk through this traversal. Yeah, so we're skipping over everything. Yeah, okay, so this is similar to what we need to do, or what we had to do before. So we need to do sum plus the current color. So we need to do current node, val current node is this one. Get the current node, take the current node, get its children. Or hang on. That's not it. But I think I see it. Input color is empty, return 1. Oh, hang on. Damn, I don't. Let's see. Traverse child counts and then return 1. I'm still not quite seeing it, so let's walk this. So we go from gold. Oops, we want to debug this. Okay, so we have gold, right? We take the children of it. Dark olive. Dark olive has the 7 bags within it, so faded blue, that's just going to return 1. That's why. Okay, I see it now. So this is only counting the children. It's not counting this bag itself. So we really just need to map it.count plus we need to return the count of the bag at that level plus the count of all of its children. That's why. So now that should add that 3 that was missing from our count there. Shit, that wasn't it? Now we're getting almost double. So that can't be right. Let's walk through this one more time. I'm gonna get rid of this. I still don't understand why that's not working. That's So this is giving us the children, right? This is only giving us the children. And then we're multiplying by the children of that. This is returning 1. Hoping this will just stand out like a sore thumb as soon as I start walking through it. So the color is shiny gold. It is dark olive. Has a count of 1, right? Faded blue has a count of 3. Why does that have a count of 3? Faded blue contains no other bags. confused as to why faded blue. Oh, I see. Okay, so it's the dark olive bags that contain 3 faded blue bags. So that's going to be 3 because faded blue contains no others. And then I'm actually going to temporarily just do, I'm going to have a val result, and then I can just take a look at what should the result be, and I'm going to return the result. I'm going to set a breakpoint here. We're going to set the result equal to this. It's funny, like these, I feel like 90% of the time that I spend on admin code is just debugging stuff. Like the problems aren't that hard, but it's like just wrestling with little subtle bugs and the recursion or whatever is what takes the longest amount of time. But we're getting there. I feel like we're close. As soon as we nail this, then we can run it against the whole input. So I'm gonna just skip this. So dark olive has 7. So dark olive contains 7 other bags, 3 faded blue and 4 dotted black. So that's what we expect. Okay. So at that level, for this color, that's what we expect. Vibrant plum contains 11. And the 11 bags within each of those. Okay, so that's what we expect. Shiny gold. So we're still missing some. So we are missing these 3 here. Yeah, because like we really aren't counting we're just counting the leaf nodes, like the very bottom leaf nodes. I think the problem is as soon as you add this, it takes you're taking the product of this. And then you're returning that product up above, which is kind of what you want to do though, right? So you want to return But yeah, that is what's happening, is we're skipping over this 1 and this 2 here. We do want to return a sum of this level. God, this seems like it should be so obvious, but I'm having trouble with it. I need to walk through this. So the reason that I'm going to draw out this map. I wish that I could share this. I'll describe what I'm drawing out though. So we have shiny gold at the top. Shiny gold is the parent of dark olive. 1 dark olive, and then 7 I wonder if we just need to return the, if we need to just return the number of children at this level. Is that what it is? Plus input size. Is that what it is? Let's see. No, that's not correct either. We really need the current node's value. I might actually need to pass in a bag node here. Like I was doing before. I still don't quite understand why it.count plus it.count first child count isn't working. Let's try that again. I'm just hoping that something stands out to me here. So this dark olive is returning 14, which is actually not correct. It's double what it should be. I wonder if this needs to be tail recursive, so it gets the count of the immediate children, and then it adds that to the traversal. So here's the count of the immediate children. I think that's maybe what we're missing. We need to count the immediate children, sum that up, and then we add that sum. I'm going to say val children is equal to here this input color. Children dot child counts is this, and then child counts plus traverse child counts, and then I'm going to do plus children dot I don't know if this is going to be any different, though, to be honest. I think the problem might be that we're kind of increasing geometrically. Color. Is this any different? I'm sure there's some just glaringly obvious bug in this code that I'm missing right now because I'm on camera. It's the same. No, it's the same deal because we're double counting somewhere. Yeah. Okay. Okay, we're debugging. We're back to square one. So then the shiny gold can have I wonder, let's see. Faded blue contains 0 other bags. Dotted plum contains 0 other bags. Single shiny gold must contain 1 olive bag. And then the dark olive contains 7 of whatever. And then I'm going to mute this. Okay, so shiny gold contains 1 dark olive and then the 7 bags within that. And then it contains 2 of the vibrant plum and the 11 bags within each of those. 11. So that's 22. Okay. So we need to count. I'm writing this down. I'll figure out a better way to share what I'm writing down, but I'm just kind of working through this problem in my head. So at this level we have, let's see, 2 plum, 2 times 11, 32. So at this level we're just returning this 11 up here. This is 24, and then this is 7 and 8. So I'm still missing how I'm double counting. is maybe the base case is wrong. So let's see this here. Okay, so dark olive is 14, so this is already wrong. Dark olive, it's multiplying this. I guess maybe like an order of operations thing. No, it's still doing it. So dark olive, the children are faded blue. Faded blue 3. Dotted black 4. Maybe what I want to do is add the children together. And then traverse and add those. Because I think what's happening here is the count of the, oh, that's one of the problems. So it dot count. Let's see. So why is this behaving this way? So children, faded blue contains nothing. Dotted black contains nothing. So this is kind of weird here that this is returning 14. We're already starting to double count here at this dark olive level, and I'm not totally sure why. Faded blue, count of 3. And then the plum is 22, so it's almost doubling whatever's going on here. So I want to see I do want to see the faded blue case. Faded blue, and then that's going to return 1. Maybe what's going on is that it's this multiplication here. I still don't completely understand why this is happening, but reverse children, color. If I get rid of this product, we do need a product somewhere. And we don't have the current nodes count. So in one case we're undercounting, but in another case we're overcounting. I think what I might need to know is the current nodes count. I think that might be the issue, is that we're never accounting for the current node. And then this is causing it to multiply geometrically as it goes upwards. So this is where we're undercounting. So we have 29, but we're expecting 32. So I think I might back up on what I had decided earlier, which is to pass in this node here, this bag node. bag node. I'm going to pass in this bag node.color. Nope, bag node, bag node, bag node.color, traverse child nodes. Plus bag node.count. So the current node count, we need to make sure that we count the current node. And I think what must have been happening is that were we double counting the children by adding it to this product? And now why is this complaining? Traverse child count. Oh, I see. We just need to pass in it here, the full bag node. So now I need to go back and make a bag node again of this shiny gold and 1. And I'm going to set a breakpoint here. And we might need to subtract that 1 off again, which is a little janky, but so this 8 is what we expect here with the vibrant plum. 35. Shit, we're still over counting. And I don't completely understand why. I might need to do a little bit of debugging and then come back to this and just kind of step through my code. And I don't want to subject the internet to this because it's already been over an hour making this video, so I need some time on my own to think through why it's double counting somewhere. And it's interesting that this is off by 3 because the previous one was off by 3. And yeah, double counting somewhere. Okay, so I'll be back. I'm gonna make I'll make another video once I have this all debugged. Okay, yeah, thanks for watching.